All right, so graphing an absolute value of complex numbers, this is pleasantly easy, okay? So first thing we're going to talk about is the complex plane. It looks an awful lot like the coordinate plane. Okay, just like the coordinate plane, we have two axes. Okay, but instead of calling them the x-axis and the y-axis, okay, the horizontal axis is called our real axis. Okay, and the vertical axis is called the imaginary axis. Okay, so this is what we use to plot complex numbers on, right? And it's pretty straightforward. So let's take a look at these guys. All right, we're going to graph these complex numbers. So this one, I've got a real part of 6 and an imaginary part of 4i, right? So I'm going to plot a 6 on the real axis and a 4i on the imaginary axis. So here, right, here's my real axis. That's not an x, that's not a y, right? So on the real axis, I'm going to 1, 2, 3, 4, 5, 6. And on the imaginary axis, I'm going up to 4. And there you go. That's that complex number plotted on the coordinate plane. And you're thinking to yourself, Miss King, isn't that the same thing as plotting 6, 4, the regular point on a regular coordinate plane? Yeah, pretty much is. Okay, this guy right here, -3 plus 5i. So -3 on the imaginary axis and +5 on the, that was backwards. -3 on the real axis, +5 on the imaginary axis. Right point, I said it wrong. All right, this guy right here, these are the two that'll throw you off. This one is a real number, right? So on this one, the imaginary part is 0i, right? Because it's not written there. So I'm going to 4 on the real axis and 0 on the imaginary axis. And then this guy, right, my real part is missing. So my real part must just be 0. So I'm going to 0 on the real axis and -6 on the imaginary axis. So there it is. Like I told you, refreshingly easy. Okay, so that's how you plot complex numbers. Love it. All right, absolute value. I'm going to warn you now, this is the number one thing people get wrong on their test, not because it's hard, but because it's actually quite easy, and then they forget how to do it. So pay special note to absolute value of complex numbers. Okay, so here's how this works. Okay, absolute value is by definition the distance that a number is from 0. So that is what we are looking for. So let's take a look at this, right? So if I were to graph this number, 6 plus 4i, so 6 would be here, 1, 2, 3, 4, right? That is what my point is, right? That's where my point is. So the absolute value is the distance that is from 0. Well, this is where 0 is, right? That's a 0 real and 0 imaginary part. So I am looking for that distance right there, right? This guy is what I am looking for. Okay, well, conveniently, we have a method in our back pockets for how to calculate that, right? Because I can pretty easily construct a right triangle here where this side is 6, which I know because I went over 6 to get there. And this side is 4, which I know because I went up 4 to get there, right? And now I can use Pythagorean theorem to figure this out, right? So I know that 6 squared plus 4 squared equals my distance squared. So that's 36 plus 16. And then 36 and 16 is 52, I think. And then when I square root both sides, let's see, a perfect square that evenly goes into 52. 4 does 12 times, so 16 goes in there. Ooh, sorry, I can't break this one down in my head right now. So I'm going to birthday cake it because that's my backup method. So 2 into 56 is 26. Yep, right? 2 goes into that. 13 times 13 goes into that once. All right, so 2 root 13. Okay, so 2 root 13 is going to be my answer here. It's technically positive or negative 2 root 13, but distances are always positive, so it's just 2 root 13. Okay, this guy right here, same idea, right? If I were to plot this point, this would be -3 and then 1, 2, 3, 4, 5. So that's that right there. So I'm looking for this distance, and I can build this triangle, right? Where this distance here is -3 and this distance there is 5. Okay, distance is always positive though, so really I can ignore that and make just +3. Right, and then what am I doing? Well, I'm doing 3 squared plus 5 squared, and then I know eventually I'm going to take the square root of it, right? So this is the square root of 9 plus 5, which is the square root of 14. That doesn't simplify, so that's my distance. All right, excellent. All right, and then this last one, so this one with a little bit of thinking, you can make it easier, or you can do the math out, right? -6i would be here, which means I'm looking for that distance, right? And how far is that from 0? It's 6 spaces. I literally just counted 6 spaces to get over here. It's 6 spaces. So 6. 6 is the answer, right? But alternatively, you could approach it kind of the same way we did this one, right? Where I'm looking at this and I'm saying, well, if you think of it as a coordinate, oh, I plotted the wrong point. Oh man, if only you guys were here in my class, you would have yelled at me. That's not where -6i is. That's where -6 is. My bad. -6i is down here. But distance is the same, right? That's still 6 spaces. Okay, so, oops. That's my distance, right? But if you wanted to look at this in terms of a point, you could look at this like it's 0, right? That you've got 0 for your real part. And what we've basically been doing is squaring the real part, squaring the imaginary part, and then square rooting it. So you could look at this and say, oh, well, that's 0 squared plus 6 squared, which would get you to the same place. Okay? So shortcut is it's just the square of the two, the real part, the imaginary part. Notice that I didn't use the I at all. Okay, so it's not 5i that's being squared. Okay, but I'm squaring those two coefficients. So that's your shortcut. But if you can't remember how to do it, this totally makes sense, right? So you can always fall back on this to remember how to actually calculate your absolute value just by logicking your way through it rather than memorizing a formula. Told you that was going to be easy.